Okay, good morning. Um, for this tutorial, I think we're going to continue with the whatever that we're discussing for the last week discussion on assembly language, and today we're going to just continue with a few of the very common commands that you see in a lot of codes, especially those that deal with LEDs and whatever that you're doing in your lab. I'm very sure that this week you'll be doing similar stuff with assembly language, and it's very important that you pay attention to the few common instruction sets. I will be pasting something on the, including something on the Moodle, okay, list of instruction sets, common instruction sets. I need you guys to go through. I think some of you has been requesting me to to have discussion on the lab. You're not very familiar, but so I think this tutorial will help. It's not exactly the same as your labs, but I think it's related. So just have a look. In this tutorial, we'll be discussing the application of several assembly language commands and the equivalent in C. Okay, so whatever that we've discussed in C, the I/O, the P1 out, P1 in, and all these kind of things. Please go ahead and study. I've repeated so many times that I do not want myself to be cliche. Okay? So this we'll be discussing on the few common instruction sets, and all these common sets, all these instruction sets are something that you've seen using C. Okay, so we just go ahead. I think this is something that is familiar to you. You've seen this in the textbooks. Okay, so you look at this code. Okay, so I'm going to explain to you. Just assume that no, this is one of the questions appearing in your finals. Assume, not to say that I'm saying that this will come out in the final, but just assume that just to for the sake of discussion. Okay, so this format is this is the reset vector. Okay, we know, and this is the format. We know that it does something. This code does something. So just maybe you can take a pause, or I'll include this PowerPoint for you guys to really try to check out what does this code do, and roughly, more or less, that you guys will be dealing a lot with blinking LEDs and so on and so forth. So just try to have a look, and you can actually come up with a guess what does this program actually do. I'll just check the recording. Okay, it's good. Okay, so we look at it line by line, section by section. I'll divide it into several sections. Okay, so from these 3 lines, I'll divide it into section 1, main loop. Okay, on section 3, off section 4, and this is the part divided into section 5. So I'm going to explain section by section. That's easy for you guys to actually understand. Again, try to pause this video and try to make it like an exercise if you can actually understand this. Very important. Assembly language is very important. There's a reason why it's placed at the end of the lecture. We had I think lecture tutorial 10. Okay, so we are almost at the end. Not much stuff is actually covered in the whole syllabus. A lot of just theories, and I think the interrupt and the assembly language are 2 of the main items that I want you guys to just put focus in. Okay, so you look at section 1. Section 1 is move something to the stack pointer. We know that you normally assign some address to the stack pointer. The address is normally after the RAM section, and we know that the second line, okay, the move W, and something to do with watchdog timer. We know that this section actually disables the watchdog timer. Again, I just like to repeat, if you should go through some of my lectures. I've spoke about this a lot of times. Watchdog timer, if you don't disable it, you need to service it. Okay? If you don't service it, your whole program will crash, and continuously go to reset mode. So questions might ask you, what if you in section 1, okay, the first 3 lines, what if you do not disable the watchdog timer? What will happen? Ultimately, you need to service it, else your program will crash. Okay, now the most significant part of this program is this line called bit set byte, and this is you already know that this is a P1 direction register. It enables or disables the it defines the pin as an input or output. Okay, so the section 1 is basically to set whichever pin as input or as output. We know that we want to define, this code is basically saying that you're defining the second most significant bit as an output and the last bit as the output. The rest will be input. Okay. So you know that in C programming, similarly, it's this is the equivalent code bit set. The rest is a bit masking method. Again, spoke about this a lot of times. I think I've covered this in several tutorials. Please check it out. Okay. So this is the equivalent in C. Sets the 7. Is it the 7 or the 6? Okay, I'm sorry. Yep. If this is first bit, second bit. Okay. So if there is a byte, okay, and it's not 0 index, then it's a 7. Okay, and first, okay, the least significant bit and the second most significant bit part as an output. Again, if you do not declare this as output, that means you cannot use this pin as output. Okay. Now section 2. Section 2, it's something new. Check out the PDF that I sent to you. Okay. So we know that it's something to do with P1 in. P1 direction is to set the direction. P1 in is basically to check the input of the port 1. So in this particular case, is a port 1 in register. You can basically, this is only a read-only register. Okay, and this bit B is basically just used for normally for reading. It's a bit test. Okay, bit test, bit set, and bit clear. All right. So you want to test the 4th pin, the 4th bit. Okay, in port 1. Okay, so if you look back into your you guys are doing a lot of the projects with the MSP. I think a few labs, 2 labs if I'm not mistaken, with the MSP. So you know that there are 40 pins or so, and each section of these pins are separated into ports. Approximately 8 pins to 1 port. Okay, so you know that okay, you want to check this particular port, is it a 0 or a 1? Okay, so if this particular pin is connected and the external input is a 5 volt, you can check. Okay, so this bit will give you a 1 or a 0 based on which one you define. Right? So it's defining the 4th bit. You want to check the 4th bit. Okay, it will give you an answer whether it's 1 or 0. No, if let's say it's you are doing this and it affects the carry bit, jump if carry equals to if carry equals to 1. Okay, so this particular instruction sets affects the carry, and if let's say the carry flag, okay, is set, means to say that it will move to jump, else it will go to on. All right, so that's for the section 2 of this code. Okay, this line at the main loop. Now what are these? Again, I like to repeat. Again, I repeat a lot of times. These are labels. In assembly language, there's no such thing as if else or whatever. You only have that in C programming. This one is labels. This one is the opcode. Okay, the mnemonics, and these are the operand. And you have labels, but these are not the labels. These are just remarks for me to explain the codes to you. Okay, you have labels, you have comments. Okay, so comments, these are tables and you have comments here. Let's say, for example, very well could be you know, some comments here after the semicolon. Okay. Section 3 of this code, you can see that bit clear and bit set, you know, it sets 1 bit and it clears 1 bit. Now bear in mind that both of this bit you have already declared as output. Okay, only after you declare as output, it will take effect. Okay, because in section 1 you already declare this bit and the last bit as output. So mean to say, when you run this part, section 3, 1 bit will be the last least significant bit will be clear, and the second most significant bit will be set. All right, so it depends on whatever that you have here, the value that you have here, the source. Okay, so this is destination, this is source. All right, so you know that it either go on or go off, right? So section 4, look at it. Before that, I hope you guys can actually convert it into the equivalency programming. Okay, so I just did one for you. Okay, there's 2 lines of C programming, one for this line and one for this line. So this one is basically bit clear. All right, I did for you the bit clear. Okay, bit clear is this one, equivalent to C programming. Now try to test yourself whether you can come up with this equivalent of C programming, this line, right? Section 4 sets the first bit of P1 out, means to say that will be 5 volt, port 1, 6 will be 0 volt. Okay. Okay. So section 5, all right. Section 4. Okay, it is the opposite of section 3, in which this one will be set. This bit will be clear. So it's the direct opposite. Okay, it's the direct opposite, right? Okay, and section 5 is basically, you know that this section is basically a delay. All right, a delay program here. So you know that you assign this into R15, and this value will be decreased in every round until 1834 is finished counting. So you know that try to relate with this lecture for this week. This absolute addressing mode means to say, absolute addressing mode means to say that the value is directly inserted into a register. So this type of addressing mode. Okay, so it counts 183520. Then this is basically a delay program. Section 5 is basically a delay. So this is the code that with all the comments. All right, so I've released for you. Okay, now if the questions might come up with something like this. Okay, it has come out before. It might ask you to do some analysis. What is connected to this hardware? Okay, you know that there's 2 LEDs. Okay, you refer back to the comments. Okay, apparently one is a green, one is a red. Okay, so this is the actual one. But questions might ask you, what is this program doing? What do you think will happen? Which pin should be connected to the switch? Which pin should be connected to the LED, and so on and so forth? You might give an in-depth answer. Now, when this question come out, please give an in-depth answer. Okay, don't give a short answer. Please use your common sense. If questions is about 10 marks, definitely you'll be expecting a lot of explanation. It's not going to be one line, right? So if you can guess, if the question is 10 marks, you know that it's going to be very detailed. This is a bit blur because I got it from the internet. Something for you to talk about, in the it is not a final question. It's something that I got from the internet. All right. So this is just to basically, this is what we'll be learning in this week's lecture, tomorrow's lecture. As you can see, you need to fill in the blanks and try it for yourself. Okay. So this is indirect. Okay. G and H is basically an indirect addressing mode. This is basically This is basically absolute. Okay, H is F is an absolute addressing mode. G and H is indirect, and I are basically immediate mode register addressing mode. Okay, so try for yourself. I'll give you the answer soon. This part of the lecture will be discussed tomorrow. Okay, so do join me for the lecture tomorrow. We'll be discussing more about the addressing modes. Okay, so this tutorial, basically we've talked about my greatest worry. Some of you are still not able to read codes. Okay, it's you can see it's actually quite obvious from the lab. Some of you are asking me what does this part do, what does this part do. So the best way to learn about the codes microcom is by actually doing the labs. So knock yourself out doing the labs. Okay, if you have not enough time, let me know, because there are sections that I can leave the night sessions open, okay, for you guys to do. Whoever wants to just have extra time, knock yourself out. Okay, you have a lot of time. Some of you might want to access it at night or whatever. We will leave the equipment on at night so you guys can access at your own time, right? Okay, so I think that's all for this week's tutorial. Join me for the lectures. Okay, so thank you very much.